Good morning. My name is Ina Eliza Manzano Valle, and this is my ICA1, and the name of my model is Diamond Fortress. So the particular animal that I was doing was the swan, and the thing that I wanted to close up on is the swan's contour feather specifically. So this is my abstract for this project. The contour feather of a swan is meticulously designed to seamlessly part water and flow along the plumes of its body. Possesses a remarkable microscopic structure. Each feather consists of veins which are lined with barbs. The barbs in turn are lined with barbules, and the barbules are adorned with hooklets. This intricate system of interlocking, latching, and connecting elements ensure that water cannot penetrate through. It is a genius of consistency and resilience, showcasing a relentless fortress formed by components so delicate they can be disrupted with a mere touch. This juxtaposition of strength and fragility epitomizes the beauty of nature's design. This is what I'm going to cover. I'm doing the nature of the swan, the process of my development, my final model, and the genius and beauty of my final model. These are the nature of swan contour feathers. They are along the surface and they are the first feathers that are going to come in contact with water. Since they are the first one to come in contact with water, they have the job of keeping water out of the swan's other feathers as much as possible. And the other nature is that they are all interconnected. So not just the outer feathers, but also in a microscopic level, the components of the contour feather, barbs, barbules, and hooklets are closely connected with one another. So here I am showing a visual of what the contour feather looks like. It has an interlocking system. As you can see, this is the hooks and this is the grooves that the hooks latch onto. And this is important because since they are positioned at the outer layer, the contour feathers have to be strong enough to keep the water outside of the body so that they can keep the streamlined shape so that water will flow seamlessly along the swan's body. So this is my process. As the first step, I tried to use hooks in fabric to see how they latch. And the second step is how I mimic the shape of the contour feather. I used the egg carton as a representative for the grooves and the wire as the hooklets. See how they latch onto each other. And this is the 3D model that I tried to make in real life. So I tried to conjoin the hook and latch and the grooves into one. As you can see, this is the hook and this is the groove. And then for the last part, I tried to experiment with other materials, more specifically weaker materials, because feathers are known to be fragile and weak. That's why I wanted to use like paper instead of something hard like cardboard. So the first thing that I did was to try to interlock two papers together. I used a square-like geometry. The next thing that I did was try to do a pattern kirigami to create grooves. So I folded the paper up so that they can represent grooves, and I used like kirigami to cut them up. Next, I tried to combine the interlocking and the kirigami bit. However, there are no grooves so they're not able to latch. So I tried to solve the problem. So I tried to solve the problem by using a triangular geometry to create grooves. As you can see, they're able to connect to one another, and it is inspired from this model. So this is the characteristics that I found out from the final paper model that I did. So the first part is that it's very difficult to pull apart. You can see that the latching and the interlocking really worked. And then we can have a hidden peek into the system so we can see how it looks. So it has a really pretty looking you can see how pretty the pattern looks like from above. So for my final model, I tried to use different shapes So I can represent that not all contour feathers are the same, but they are still able to latch onto each other because of their similar shape. So this is my final model. So it has the strength to keep upright thanks to its characteristics. This piece of paper right here is actually not touching the ground, but they're just using the other two papers as a way to keep itself upwards. They're just using the interlocking system. And there is space in between. You can see that the light can pass through, and you can see the pattern on the in the shadows. And if you look above it, you can see the consistent interlocking. It's really repetitive, and you can see the beauty in it as well. So in conclusion, the genius and beauty that I found in my model, that it is kind of poetic at how even the simplest of systems is able to withstand such forces, and within that simplicity there is a blend of control and consistency. On its own, the paper is flimsy, unstable, and weak, but within the repetitive folds, a pattern of a single cut, the material was able to improve upon itself. Furthermore, this allows the paper to connect with another familiar. The mere act of reinforcing it with another identical piece to itself, the paper's strength are increased. It is remarkable that through the continuous grit of the paper, it was able to become more than itself. Thank you for watching.